Hello, everybody. Welcome to the Oracle VM Screencast series. My name is Duan Nguyen. In this screencast, we're going to talk about application-driven virtualization and kind of understand what it really is, why application-driven. Before we go into the topic in depth, let's go through the agenda real quick. We're going to take a look at why there are market forces that make application-driven important. Some of the transformation that's going on in IT with data center and some of the challenges there leading up to the need for application-driven, and then do a double-click into application-driven virtualization, what it is, what it means, then quantifying that in terms of really what's the value of this, and looking at what we mean when we say engineered for Oracle. Before we begin, wanted to make sure we observe the safe harbor statement. This is intended to outline product, but in no way is it intended to commit or communicate future general product direction. Looking at the market landscape and the trends in the industry, we're kind of seeing the transformation and the evolution of IT that's driving toward cloud. In early days, data centers are driven by IT cost savings, so virtualization as a means to consolidate the footprint of servers to reduce cooling, reduce heating, and get less space and more utilization to allow IT to make do with more with their constantly decreasing budget. The next phase to that is really now that I've actually consolidated my boxes, my servers, there's still a lot of applications out there, and so that next wave is really looking to how do I reduce my application footprint? A lot of enterprise applications deployed out there. How can I get better use of the server with fewer application footprints? In addition to that, though, there is the need to also deliver application services rapidly, and that's really fueled by the competition in the marketplace, mobile computing. Today, we have the need to get at information very, very quickly. As end users, we don't quite care what application it is that's in the back end that's serving up the data, as long as we get the map information to where we need to go, or as long as we get the information on that next product that we're researching for. The smarts behind the scene, the applications have to actually deliver the services to the end users. Then the next thing that we see in that wave is really modernizing the data center. Now, with the economy in 2008 or so, that's impacted IT spending significantly, but as we're starting to see with industry data, a lot of the IT groups are now doing their refresh. They're going through their hardware as well as software refresh cycle. As part of that is to modernize or to upgrade that infrastructure as well, so that the underlying fabric that delivers these services are a lot more flexible and agile to getting the products and services to market quicker. So that transformation in combination is happening, and depending on the geographic area that we're talking about, in the U.S., we're seeing a lot of cloud adoption, and then in other regions, the consolidation at the server and application level are still ongoing. When we talk about transforming IT and modernizing the data center, what we're really talking about is that the data centers are no longer an assembly of servers and cooling and storage and network that with applications running on them, but really they're viewed as service centers. And IT talks about services, charging for services from IT rather than charging for applications served up. As part of that, what it's doing is that it's making IT a service center, and in order to actually be a service center, there are key ingredients to making that transformation happen smoothly. One is making sure that the various components that make up that new cloud infrastructure is integrated. And integrated is basically from the infrastructure all the way up to the application. making sure there's interoperability in there, and that interoperability is hopefully certified by the vendors so that you as a customer isn't subject to experimentation or delays or issues as you try to access services on a website, for example. And then one of the other thing is primary ingredient is that infrastructure has to be scalable, meaning if I wanted to be able to add a new database for a new set of service to accommodate people signing on to a particular service, I need to have a database that captures all that information. My servers have to be able to have the right amount of memory, storage, network bandwidth to be able to allow me to scale. And the important thing is that I don't have to go out and do another acquisition of all of these infrastructure. In other words, what I started to build out should be able to scale as I scale my operation. The second flavor to this ingredient of enabling business availability is availability. System needs to be on. It needs to be ready for when my customers want to access this. Whether I'm a hotel site that offers the ability to book rooms online or airline ticket purchase or an auction site, that has got to be on, because once a consumer has that URL in mind where they go to do business, it's basically they're trained to go there. And so it needs to be there, it needs to be on, it needs to be reliably on. Whether it's a busy time for Christmas that I want to go shop, I need to be able to get my transactions processed quickly and efficiently, or during some sort of a sale or a promotion. So availability is key. Also in case unforeseen disasters. So, for example, there might be a storm, there might be floods, whatever the case might be, I need to make sure that as I modernize, as I build out my infrastructure, that I have got to have the infrastructure to be able to ensure both downtime that's planned and unplanned. The other flavor to this need is agility. I have to be able, for example, move my workloads around. If I have a series of ATMs at a bank that allow for my customers to withdraw money, I know that Fridays are typically busy cycles, so I need to be able to allocate compute cycles from other servers that I'm not using to the ATM servers so that customers can come and get their transactions done quickly. The fourth criteria of transforming IT need is that underlying layer that allows for my infrastructure to be nimble, to be flexible, to be scalable, typically is a hypervisor. But just simply having a hypervisor to accommodate that infrastructure is not enough. That hypervisor needs to be able to do more than just provide you the abstraction to the hardware. Doing a little bit more drill down, what we're seeing with our customers as top of mind for IT leaders is in virtualization and cloud deployment. In terms of business priorities are faster time to market for both products and services. What that means is that the pressure on IT is immense. If we think about application or services, no longer do we have a year or 2 year to, especially in the realm of commercial that have services and products online, 1 or 2 years to get product to market is really not a cycle that allows for businesses to be competitive. Companies look at getting their services out and they're measured on a quarterly basis. We're talking about probably a 3-month cycle for product requirement to product accessible by customer. So immense pressure on IT. What that does is that it makes IT have to go back and say, okay, what am I doing with my technology? So in terms of technology priorities, what that does is it impacts the application lifecycle, the management of it, the services of it. It's a lot more complex then in terms of how do I allow for my company to flip the switch in 3 months and push all of this out, and by the way, make it accessible to thousands and thousands of users in a timely manner. The second business pressure is really to reduce the cost. That's sort of the all-time mantra that IT sees. What that does is it puts a lot of pressure on IT in that fantastic server rack with 60 nodes or whatever that capacity is can I afford that? Or do I need to get things that have more value with that? So spending for IT on all the different components as they operate their data center is also very, very much squeezed. What that means is that IT now has to go and source supplies from vendors. Typically, they'll have to go to multi-vendor. Now, the complexity there for IT is that, first of all, it takes time to research who's got the best switches, the cheapest set of servers that gives me maximum capacity, that, by the way, works with my software licenses. That takes a lot of time. The other pressure that the business leaders have is the need to drive revenue higher and higher. So every quarter at a meeting, quarterly business reviews dictate that we must show strong performance in our products and our ability to perform, not just for the company, but also if it's a public company for our stockholders. To drive higher revenue, product revenue, means that IT needs to operate in a way that allows for the company to be profitable. One example may be that quality of service has to be increased. For example, if I'm a hotel that's in the range that competes with another hotel in the star ranking, I want to be able to allow for customers to come to my site and book that hotel and find that cheapest rate in the quickest and shortest time possible. Because if not, that customer can go to that next 4-star rated hotel and be able to book a room in better time. And so therefore, my business is now basically dictated by the level of service that I can deliver at the very front-facing when customers begin to reach my interface with my IT services. And that's difficult. In doing that, for the technology folks, they must also ensure that whatever the components that they assemble from these vendors have to be compatible. The drivers for the network and the storage have to be compatible with the servers and so on. What that means is that if that isn't ensured, then we run into operational risks. That risks the business side of the house from being able to meet that quality of service to their end user. It's a vicious life cycle that has a lot of multi-dependencies on each other here. And then also for business, it's really getting a lot more operational efficiency to be competitive. From the technology side, if I do meet that, I need to make sure that I get good support from my vendors. So I've built my cloud infrastructure with multi-vendors that have different products in there, making sure that getting timely support from all of those vendors, that making sure every layer is compatible with each other is also a challenge. So all of that makes a really complex set of challenges that IT is facing. So that's kind of at the business level. If we look at where most of the applications, the complexity reside is really, when we talk about services, it's really the application that we're talking about and the application life cycle. Because of the nature of hardware, there's a few set of things that can go wrong. With software, particularly, we're talking about complex multi-tier software applications that service a business. There's a multitude of complexities involved there, and that's where a lot of time is actually spent. In a typical application lifecycle, there's usually 4 areas. There's likely to be more, but these are the 4 very common areas. You've got to develop the application or the code, test, deploy, and then update or upgrade that. And then basically the cycle repeats itself. In each part of the application lifecycle, there's complexities involved. For example, say I'm an online vendor and I need to add a feature to my to how customers go purchase for products. I need to make sure that new feature that I'm introducing, that new set of, the new database table, that update to the web server and the app server has to be compatible. For QA, what that means is that if we recall in our previous discussion where we talk about life cycle is no longer in a matter of years, but really in weeks and months. So in a business cycle, a quarter, we're talking about 3 months, both development and test and rollout. So for QA, what this means is that QA needs to actually stand up an environment very, very quickly so that they can then test and make sure that this new feature gets delivered properly. Not just that it works, but that there is sufficient capacity in the database, there is sufficient capacity in storage, there is sufficient availability involved, so there might be a cluster environment. So it's not just a matter of putting up a server and pouring software on there. That whole series of testing has got to be solid, and that has to be done in a very, very quick amount of time. The next cycle to that, after the application is tested, is now you have to roll it out. And as we mentioned earlier, the immense competitive pressure for business today, everything is got to be done yesterday or ASAP. So making sure that for operations, making sure that the ability to roll this out and being able to do so properly and making sure that there's load testing performed, that has been performed, making sure that all the dependencies and operations is ready to go is actually also another complexity. And then making sure that the management policies are properly implemented so that once you push that button go and sort of spray them this out to production, that it does work and it works properly. And then that same set of issues repeat again as you have to update or upgrade your application. So the life cycle, the application life cycle, is really where a lot of the challenges reside for IT. So this is where application-driven comes in, because at Oracle, what we really, when we talk about server virtualization, we look at the entire computing stack and the consideration of IT's challenges really top down. So making sure that when we say application-driven, that simplicity is at the heart of the issue. We simplify the complexities that's involved there. And one way so basically there are 4 ways to do that. One is making sure that all the components associated with the hypervisor or the virtual machine, the virtualization layer, is easy to deploy. Not just the hypervisor itself, because that commoditized technology has really advanced to where all vendors have actually been able to make that a very, very quick process. But easy to deploy for also the dependent application stack. So if I wanted to virtualize my existing hotel reservation system, I need a system that allows me to do that easily, from the database to the app server to the web server to connections to my storage to access to networking. In other words, really, really simplifying that. The second part is making it easy to manage. And management is really the ability for IT to realize the savings, because unless and until you can automate that process, you can build in your policies to control, manage the different layers, and do that easily, the investment that's made is probably, the ROI on that's probably going to be very low, unless that's easy to manage is thought through. Ensure compatibility, as we mentioned. As companies move more toward a flexible infrastructure, multiple pieces have to be assembled, and those multiple pieces need to be able to talk and work with each other. The ensured compatibility for that stack is really, really important. And then also making sure that it's easy to support, and that's the ongoing care and feed. If I have an application, if I have a system that I've set up that in place that requires a lot of effort to support, again, my ROI is going to be very low. These are really the goals that embodies application-driven virtualization. What we do is we actually look at the entire stack, as we've mentioned, not just from the hypervisor level again, but we look at the data store, which is the database, the servers, storage, and networking, what has to go out to end users in the end user environment, applications and middleware, and operating system. And then taking all of that and creating an integrated stack so that what we end up providing is the easy to manage, the easy to deploy, a compatible stack from a single vendor. This is where Oracle VM comes in, and it's really at the core of Oracle's cloud and private cloud foundation. where the VM lifecycle and cloud management solution is tightly integrated, and that's Enterprise Manager. Oracle VM supports both X86 and SPARC architectures, and also both Oracle and non-Oracle applications. In terms of workloads, Oracle VM supports Linux, Solaris, and Windows. So part of that integrated vision, what we really strive to do is making IT easier and making the transformation of IT manageable and keeping it low cost moving forward, ensuring applications easier and infrastructure easier and faster for deployment. So the analogy that I would draw to that is, think of it from a consumer point of view. Today you have your app store, whether it be Google or your favorite Apple app store or iTunes. You simply go there, download the app onto your device, and it's working. There's very little configuration. There's very little care and feed about compatibility and all of that. So the same idea that we're trying to do is to translate that into the enterprise applications, where you can actually go to Oracle Software Delivery Cloud, download the packages, or in this case, what we call Oracle VM templates and assemblies, and these are basically pre-built, pre-configured, so that you can then quickly deploy them onto your servers. That's the idea, and that's what we're going with application-driven virtualization. Translating the idea, that was sort of a consumer view at application-driven. Translating that to an IT view, application-driven really takes the top-down approach versus the traditional virtualization where it's a bottom-up approach. So the bottom-up approach basically delivers a hypervisor that provides the abstraction to the hardware at the hypervisor level for your computing environment. And typically, these hypervisors then allow for you to deploy a guest OS onto there. And then the management console comes with that, whether it's management from the hypervisor that's included or management from the OS. And that's depending on what type of OS you end up putting on there, what type of hypervisor you end up adopting. And that's the view from the traditional server virtualization. Business applications, middleware, database, not part of the hypervisor that is shipped. Contrast that to the top-down approach, which is the application-driven virtualization approach, is that we take a much more holistic approach. The hypervisor is basically but a component of the bigger stack, and that component needs to be able to talk, integrate, interoperate, be compatible, choose the word, but that is a component of the larger ecosystem, and that must work and must be integrated and must be compatible with all those different components. So that's what really application-driven is all about. It's designed to provide the abstraction to the hardware, but also it's designed to provide compatibility and integrated management with all the components on top of that, starting with the OS, the database, the middleware, and the business application. What does application-driven include in terms of its architecture? Oracle VM templates is one component of that. Oracle Virtual Assembly Builder is another, and these are the key enablers for allowing for rapid application deployment or rapid private cloud deployment. The second component of that is the hypervisor, or Oracle VM, has its roots and integrations with the database, the operating system, the application, the middleware, and business applications built in so that Oracle can ship these integrated bundles as single image components that you can deploy in the form of a template. And that's unique to Oracle because Oracle owns the IP to every single layer of the offering, from the hardware all the way up to the management console, including the operating system. So you're not having to depend on having to assemble the operating system from one vendor, the hypervisor from another vendor, the database from another vendor, the app server from someone else, and then glue all that together in your own business. And that's what application-driven allows you to do, is that we actually do all that integration for you. The other important part, going back to the 4 key pillars of making IT transformation easier, is the ability to easily manage and control and orchestrate the entire environment from hardware to OS to software from a centralized console in Enterprise Manager. So that's really where we talk about the full stack and integrated stack. That's where the advantages come in for IT. On top of that, the hypervisor is actually certified with all of the Oracle software and hardware that Oracle VM ships with. And that certified is actually key, because you want to be able to know that if I have deployed my hypervisor, that all the other pieces are also compatible. And if it is not, I actually reach out to a single vendor to address my issues. And that's where that 4th pillar of making easy to support comes in. So as mentioned earlier, there are a couple of mechanisms for enabling rapid application deployment. One is Oracle VM templates. And Oracle VM templates are pre-built, pre-configured VM images with the complete stack of applications in there. So in this case, we're talking about database, whether we're talking about the need to deploy a single instance or a real application clusters, which is typically called Oracle RAC. So that complexity of having to deploy a 2-node cluster, 4-node, or whatever the size of your data center is completely pre-built, pre-encapsulated in a template, and that's the Oracle VM template for Oracle RAC. And that's just one example of a template. There are other templates that enable the rapid deployment of Oracle applications that support Oracle eBusiness Suite, J.D. Edwards Enterprise One, PeopleSoft, and so on. So that is where the power of application-driven comes in, is that the ability to basically eliminate days or weeks of deployment time down to literally hours. And we can talk a little bit more about that. As we mentioned earlier, there are over 100 templates that are available. Some example of them are Oracle Database 12c, the single instance, as well as Oracle RAC. Also, we talked about templates for Oracle Exalogic, Oracle VirtualBox for testing, for Enterprise Manager. And all these key infrastructure application components are pre-configured along with Oracle Linux that allows you to really quickly deploy these instances onto your infrastructure. So one of the recommended best practices as far as deploying Oracle Database or virtualizing Oracle Database is through Oracle VM templates. And just an example here is for a database, single instance database deployment. Really, we're looking at minimum requirements of 1 core, 2 gigabytes of memory or more, and then 30 gigabytes of disk space. And the efficiency for templates is built in such that it actually requires near zero knowledge from the user as far as operating system goes, as database knowledge goes, because all of that information is encapsulated so that when you actually download the template from eDelivery, what you're really having to do after that is run a script and respond to a series of questions, and then the script does the rest of the work for you. So that's really the essence of what we mean when we talk about rapid application deployment. The other rapid application deployment tool is what we call Oracle VM Assemblies. And Oracle VM Assemblies is actually a series of VMs that consist of images of your series of applications that also include deployment directives, management directives, and these VMs or these assemblies are ready to deploy, stored in the Oracle Enterprise Manager, and can be provisioned out onto your servers very quickly. When do you use Oracle VM assemblies? Oracle VM assemblies are basically really well suited for multi-tier applications because the applications are typically would be encapsulated in the VMs. How this is done, again, going back to rapid application deployment, how this is done is actually very, very streamlined. So from an end-user perspective, there is an application with Oracle Virtual Assembly called Oracle Virtual Assembly Builder Studio. And what the user would do is go into the studio, and the Virtual Assembly Builder Studio allows for that user to actually selectively click on software application images that the builder has mapped out in your environment. That then, the set of applications that have been selected in Builder becomes a reference system. Then that reference system gets assembled into an assembly. And then the assembly could be made up of, in this case, for example, WebLogic, Coherence, or your Oracle database, or your multi-tier. If you're in a business and you have an online business, if you have a buy application, that buy application could consist of an app server, your web server, your database, your custom application. All of that gets encapsulated inside an assembly. The assembly then gets uploaded into Oracle Enterprise Manager, and from Enterprise Manager is where you can actually perform that orchestration and deploy the assemblies or that entire application stack out to your server. That's the beauty of being able to basically forklift an entire application environment and then deploy it out to a different environment. It could be done for migration to private cloud, for example, or if you want to replicate one data center to another. This is really the enabler for doing that very quickly. When we talk about application deployment, let's take a look at a little bit more closely. We're going to follow the process of application deployment, looking at a typical process, then go in and look at what the templates allow you to do. So the first step in terms of evaluating this is, in a typical process or deploying the application, it's 1 to 3 weeks, sometimes 1 to 4 weeks, if we're talking about a 3 months product life cycle. So the first few days, the first 1 to 5 days, is basically to acquire and install your new platform components. That would be the OS, all the different base software. It could be the web server, your app server. The next couple of days is configuring the platform software. So configuring that web server, configuring that app server. So we're talking about probably anywhere 2 to 7 days now, time elapsed. Then the third step is to customize it so that you can manage it in the future. So you create and customize some scripts to automate that process. And depending on, how quick that script is, it could be 1 day, it could be 5 days. Some IT ops could be 10 days because you're distracted. So we're talking about anywhere between 3 to now 12 days. Then adding time to that is the time to fine-tune that whole install environment, to tweak your parameters, making sure that things are going properly, sequencing things. Then a couple days to make sure that you can then replicate that environment to build, test, and deploy. The last step is to deploy the application. So total time is about, conservatively, 1 to 3 weeks. And in that time, the platform team are involved, because the platform team are the team that's responsible for the hardware, getting the networking, getting the storage configured right. And then the application or sometimes the database team is involved as well. So you've got two groups of people that are highly specialized in this process for 1 to 3 weeks. Then we deploy the application into a virtualized environment. So in the case of virtualizing the application, let's take a look at the number of time there. In terms of the platform team, provisioning the VM, that can be automated. Provisioning the OS, I can script that, and I can probably get that done very, very quickly. The platform team is partially involved. Then we talk about the configuration process of the application. And this is still where the application team or the DBA team has to be involved. It's a manual configuration process because I get it onto the virtualized environment, but I still have to configure it. Even though the platform team has automated the process of provisioning, and that may take a matter of minutes, but still that whole configuration process has to be done. So we're talking about anywhere between 8 days to a week in an efficient organization. And again, we still need to have the platform team to make sure that they've customized the script to automatically provision the VM. And then we need the application and DBA team. With deploying application to a virtualized environment using a template, as you can see, that process that we talked about 1 to 3 weeks or 8 to 10 days is now a matter of literally 1 to 2 days or minutes, because the provisioning of the platform team is fully automated. That's completely subsumed in the template script. So I don't need to know anything about the operating system. I don't need the platform team to automate the provisioning of the VM for me. That's part of the template. Now, when it comes time to configuration, it's also in the template. So the involvement of the DBA team is really to just check out what I've installed and a sign-off, but what we're talking about is moving something from a matter of 3 weeks, potentially, to either 1 or 2 days. So what we did is we actually worked with the evaluator group to validate the efficiency of the templates. And what they found is that deploying Oracle VM using the templates for Oracle Rack, in this case it's a 2-node rack cluster, the installation time is actually about 40 hours with VMware vSphere. Using Oracle VM template for Rack, the deployment time is about 4 hours. So we're talking about a 10x reduction of time in terms of ease and speed of deployment. And then we also validated that with Oracle E-Business Suite as well. And the time here is basically 7x faster than with VMware. So the idea here is that you can actually perform this very, very quickly with the template, and we've been able to have that independently validated. So when we say we actually, for IT, one of the concerns originally we talked about is reduction of costs for IT. And so mapping that to the cost here, if we're really looking at cost, this is one area where we can highlight the cost. With Oracle VM template, so we're using the Oracle Rack deployment time as an example, assuming an average of $50 an hour for, say, DB admin time. With Oracle VM, there's a $200 cost of deployment time versus with VMware vSphere, it's a 10x cost, $2,000. So not only just the cost, but their number of steps involved. So the complexity is really, really enunciated if we look at step by step what it takes to get this deployed without Oracle VM templates. So mapping that to the lifecycle challenges that we had earlier, so imagine that the 40 hours that you're spending here, we will say, well, Duan, I don't do that all the time. I only deploy my applications with my 2-node cluster maybe only, once. So what's the big deal? It's only 40 hours. So when you actually think about it, it's actually not a one-time deployment, because if you look at an application lifecycle where you have to actually flip a test and a development environment very quickly to develop that new feature, you're talking about repeating this in terms of their life cycle. So it's actually a repetitive 40 hours cost in that life cycle, not just a one-time occurrence. The other component that's key to enabling cost reduction and ease of deployment, as we talked about, is Oracle Enterprise Manager. And without the ability to orchestrate and manage from a central location all of the different complexities, so for example, the physical server farm, updates of the OS, updates of the virtual machine. And then on top of that, let's say you want to be able to allow for self-service provisioning, enable for employees or to go and deploy their own applications on their own devices, servers in their different business units. Needing to plan for capacity or having to do to meter the services usage, you can do chargeback for the different teams within the organization. All of that needs to be able to work together in one single environment. You can't just have a management console for your cloud-based services, a management console for your OS, a management console for your web server. That's where the integrated stack comes in, is Oracle Enterprise Manager brings all this together. We talked about the application-driven, but also there are architectural differences as well. For example, the hypervisor is actually architected so that it supports up to 128 virtual CPUs. What that allows you to do is get a lot more scalability for enterprise workloads out there, which is basically two times more scalable than what you would get with VMware. Zero license costs. There is no encumbrances as far as acquisition. You simply download, put it into your environment, make sure that it works. And then once you're content with that, then you actually pay for support. And the support is actually very reasonable. And in addition to that, Oracle Enterprise Manager is included in there. And what that does allow you to do is maintain your low cost of ownership. We talked about the idea of rapid application deployment with 7 to 10 times faster. It's really what applies if you are looking at a recurring process of application deployment. And this is where the application-driven difference comes in. Lastly, but importantly, it's Oracle-driven. And Oracle uses Oracle VM in its daily operation to drive our IT. Stay connected with us. Join our communities. You can find us on Twitter, Facebook, blogs. Our blogs are very informative with all great content, from product news to tips and tricks to new assets and white papers. Check us out there. Also, YouTube. Our products can be accessed at edelivery@oracle.com/OracleVM, and also Oracle trainings. So stay connected with us. That's the end of the screencast for application-driven virtualization. Thanks very much for listening.
Hello everyone, my name is Honglin Su. I'm the Director of Product Management for Oracle VM. Joining with me, we have John Falkenthal from the developer team. We're going to share with you what's new with Oracle VM server virtualization. Before we go into the detail of the presentation, let's pause for a while to go through the safe harbor statement. Today, we are going to first talk about Oracle's virtualization strategy. So then, we are going to cover what's new with Oracle VM server virtualization, specifically for Oracle VM Server for X86, Oracle VM Server for SPARC. We have stated Oracle's virtualization strategy, which is to simplify customers' virtualization infrastructure with Oracle VM template, and at the same time, we also have done lots of integration to integrate the entire Oracle software stack. And at the same time, we continue to innovate, bring more and more value to customers. Application virtualization, this has been main theme for Oracle's virtualization offering. There's a number of virtualization vendor offers key cost-saving benefit, including Oracle VM and some other virtualization solution offering. So for example, server consolidation. And when you consolidate more and more workload into the same physical hardware, you have lower energy, facility, and labor cost. Those are the common benefit with many virtualization offering. But at the same time, Oracle virtualization strategy offers much more. We provide application-centric and application-driven virtualization, which is to top-down, with integrated management of the full hardware, software stack from server, storage to the end-user devices, and comes with integrated support. In a summary, Oracle's virtualization that really makes the software and the system easier to deploy, easier to manage, and easier to support, not virtualization for virtualization's sake. Oracle VM is at the foundation for cloud. It's at the core of the Oracle cloud strategy. With integrated VM lifecycle and cloud management solution with Oracle Enterprise Manager, we support both X86 and SPARC. All of the Oracle software product has been certified with Oracle VM. But we are not just offer the solution for Oracle. There's many non-Oracle applications has been certified with Oracle as well. So for X86, we support Oracle Linux, Oracle Solaris, and Microsoft Windows and other Linux distribution. For SPARC, we support Oracle Solaris. The reason we have been driving the called application-driven virtualization solutions, because enterprise application lifecycle, there's some challenge. So whether in the development side, from the testing, deploy, or upgrade phases, you come with a number of challenges you really want to address. So for example, if you need to add new features to the product now, and the QA team need to access to new storage and change database configuration, and IT needs to roll out application as soon as possible. Those are not trivial to be resolved by the traditional virtualization approach. So that's why we offer at the very beginning with Oracle VM template, which is a pre-built, pre-configured virtual machine to simplify application deployment. So those Oracle VM template has been pre-built by Oracle, but you can also build it yourself. Then you can download from Oracle Software Delivery Cloud, and then you can deploy it to Oracle and the non-Oracle system, and a number of Oracle engineering systems. Oracle VM has been integrated into nearly all of Oracle's engineering systems. So for example, Oracle X86, Oracle Database Appliance, Oracle XLogic, and a number of X86 and SPARC systems. The recent engineering system is a virtual computer appliance. Oracle Enterprise Manager 12c offers total cloud control and full stack management. All those features, including the self-service provisioning, capacity planning, assembly, packaging, and deploy, the metering chargeback, policy-driven resource management, those capabilities works very well with Oracle VM. It interacts with Oracle VM Manager, then offers you the full stack control and management. So in terms for Oracle VM family, it offers choice and flexibility. So from the full configuration software to turnkey systems. So the Oracle VM server virtualization software is available for X86 and SPARC. There's no license cost for you to use. You only pay for support. It provides full functionality, including all the management software comes with Oracle VM offering. Then the virtual compute appliance is enterprise class turnkey converged infrastructure system containing server, storage, network, and software, from power on to production, literally in about an hour. So next, I'm going to go over some detail what's new with Oracle VM Server for x86 and Oracle VM Manager. The Oracle VM Manager, which is a centralized management server, it provides web browser-based management. There's no client required. It can manage hundreds or thousands of virtual machines centralized. It offers advanced virtualization management capability, including centralized network configuration, storage configuration, VM lifecycle management, and lots more. For Oracle VM Server for x86, it installs on bare metal server in about a minute. It supports a broad range of guest OS, including Linux, Solaris, and Windows. We provide support for both parallel virtualization and hardware virtualization support. Then for Windows, we offer Windows parallel virtualization I/O device driver to improve network and disk I/O throughput. Oracle VM solution offer high performance at scale. It supports the largest X86 servers up to 240 physical CPU threads and 6 TB memory at this time. It will continue to scale as soon as a new system comes available. For each virtual machine, it supports up to 128 virtual CPUs and 2 TB memory per VM. The Oracle VM 3.3 is the latest new release. We offer a number of those key enhancements across several areas. So the first one is infrastructure improvement, which provide greater stability and better performance for large deployment. Then next, it offers a number of enhancements for automation and usability, so including web service API, redesigned VM console, and some additional improvement from both the UI and the command line interface. Then the next category, it offers much more diverse platform and workload support, which including, as I mentioned, for the Windows PV drivers, improved support for some of the X86 environment, for example, huge page support, better handling for the networking side, improved VLAN implementation, and enhanced Oracle VM Server for SPARC support. At the same time, Oracle VM 3.3 is ready for OpenStack. So what's new for Oracle VM Server for X86 release 3.3? As mentioned, first, the infrastructure change for Oracle VM Server. The hypervisor has been updated from Zen 4.1 to 4.3 to take advantage of some of the new built-in enhancement from Zen hypervisor. The DOM0 kernel has been updated from the early Oracle Unbreakable Enterprise kernel release to the latest, the release 3, to provide much better hardware and device driver support. Then the DOM0, the user space, has been updated from early version to the new version of the Oracle Linux 6. The server installation had also been improved. So now you will be able to leverage remaining space to host VM disk image to use as a storage repository. Then we provide the upgrade capability to allow you to upgrade from the Oracle VM Server 3.1, 3.2 to the latest 3.3 release. Then what's new for Oracle VM Manager 3.3? So first, the infrastructure side. So it has been enhanced to support larger and more diverse environment. So the statistic events and jobs will provide significant scalability improvement. The Web Logic Server, which is the core of the Oracle VM Manager application, has been updated to use the Web Logic Server 12c. The Java has been updated to Java 7. The UI and the command implementation has been switched to Web Service API. With Oracle VM Manager 3.3, we provide further simplicity with the bundled MySQL Enterprise Edition as management repository without dependency on an external database. So this change allows you to, with improved supportability, because the bundled MySQL Enterprise Edition comes with automated backup. At the same time, we provide tool for database object consistency checking to improve the overall reliability of the Oracle VM Manager. Then the Oracle VM Manager install and upgrade has been improved to allow Oracle VM Manager to take new and updated component moving forward. In this new release of Oracle VM Manager 3.3, we provide fully supported Web Service API. So it exposes the Web Service API offers both SOAP and the REST interface to allow customer and partner to program any action supported within Oracle VM. We offer developer's guide as part of the documentation sets. There are a number of the serviceability and the usability improvement. So one example is new VM console. It has been redesigned to use JavaScript and HTML5 features so that there's no requirement to install or run any additional software locally on the client computer. It removes the dependency really on the client side, the browser or the version of the Java or the OS. So this change reduces complexity and provides a more reliable console access tool. The virtual machine configuration file view is to allow you to view the VM virtual machine configuration directly from the Oracle Manager UI. It allows you, the administrator, or our support staff to help you access the VM configuration in a much easier and more directly. The inbound migration log is to, through a simple UI setting, allow you to protect a server from attempts to move or migrate other virtual machines to the server. Performance is also another area of big enhancement in this new release. The Oracle Manager, as part of the infrastructure change in terms of the Oracle Manager, the new statistic and the events model has been enhanced. Then the server notification thresholding has also been improved for the Oracle Manager performance. Then through a simple UI setting, it allows you to set up huge page support for the VM, especially you want to run the database workload in a virtual machine. Then there's also communication between Oracle Manager and the guest VM to leverage the VM, the guest edition to improve the messaging to the guest VM. There's many other code changes to improve the overall performance of the Oracle VM infrastructure. The network improvement, including for the improved VLAN support. So we make the customer much easier to configure the VLAN at the individual server level. So we removed some of the previous restriction which require the same VLAN setting across entire server pool. In addition, we add support for the HTTP proxy when you want to import an OVF assembling virtual disk or the virtual CD-ROMs. Security enhancement, which is also as part of the new Web Services API implementation, we consolidate a number of those services, so that's required ports to communicate between the Oracle Manager and the agent. Those ports has been reduced. So those changes also reduce potential risk when you want to expose some potential attack vectors available to malicious users. In the Oracle 3.3, now we also implement certificate-based authentication. So the Oracle agent now use SSL certificates to authenticate requests from Oracle Manager once the server has been discovered. So those certificate-based authentication can be used for all Web Service API requests to ease automation while retaining a better security model for authentication. As part of the Oracle VM Manager 3.3, we provide further enhancement to unified X86 and SPARC management. In this new release, we address the top SPARC customer request for new deployment. So first, we expanded more storage support when you want to use Oracle Manager to manage Oracle Server for SPARC. We beginning the support with Oracle Manager 3.2. We start with NFS as only supported storage repository. So now in the 3.3, we add support for Fiber Channel, iSCSI, and local disk for guest VM, in addition to NFS. We also add the ZFS volume and the local disk as storage repository. We provide the ability to configure the VM HA, which is guest VM auto restart, and now guest VM to restart on failure by a simple UI setting. We also allow configuration of redundant I/O service domain for improved system availability. Those has been very popular for our SPARC customers. There's many areas of the network improvement which benefit both x86 and SPARC. So in that regard, we have consistent feature set running across x86 and also SPARC virtualization management. Then specific to SPARC, we also have the package management for SPARC upgrade, especially when you want to upgrade the Oracle VM agent that's using the Solaris IPS packages. The Oracle VM Storage Connect plugin, so which we introduced since Oracle VM 3.0, which is to allow the storage discovery and provisioning using from the Oracle VM Manager. There's a number of vendors, they provide the Storage Connect plugin. So after we release Oracle VM 3.3, NetApp, EMC, and the Oracle Sun ZFS storage appliance, the Storage Connect plugin has been updated to support Oracle VM Manager 3.3. So now with Oracle VM Manager 3.3, then you will be able to discover and provision those VM, the storage connected to Oracle VM infrastructure directly from Oracle VM Manager UI. And there are many more storage vendors that are going to update the storage connecting plugins. As we look to the future, when we talk about the virtualization strategy, we will continue to innovate, bring more value to our customer. The management integration and the full stack optimization, that has always been our priority, which brings tremendous value to our customers. Many customers really like the Apple iPhone experience. When you access to Apple iTunes, the Apple Store, you update your application instantly. So we want to bring the same ease of use to enterprise application deployment. So that's the area we will continue to improve. So for Oracle VM Server for x86, the dump zero, so we will also continue to bring the updates from Oracle Unbreakable Enterprise kernel, so that new driver and new hardware support, so which bring direct to Oracle VM Server as well. The Zen hypervisor, which is our architectural choice for the hypervisor. We continue to contribute to the upstream Zen development. At the same time, we prototype some key features as part of the Oracle VM solutions. One example is PV Edge, which is PV in an HVM container to bring the benefit of both parallel virtualization and hardware virtualization. Then there's also storage and network enhancement. We will continue to advance in the software-defined network. We continue to improve performance and provide enhancement in the configuration option, which is through Oracle VM Manager UI. The Oracle VM Manager continues to be the control plane for the virtualization now. Today, it offers one set of API for SPARC and x86. It brings common user experience across both x86 and SPARC virtualization platform. At the same time, we also explore support for the lightweight OS virtualization, such as Linux container and Solaris zones. The Oracle VM Manager itself is required by Oracle Enterprise Manager for full stack management. Then the Oracle VM Manager can deploy virtual appliances. So the API is also being used by Oracle Virtual Assembly Builder. So next, I'm going to transition to John to talk more about what's new and exciting enhancement for our SPARC customers.
Thank you, Honglin. My name is John Falkenthal. I'm the Senior Engineering Director for the Oracle VM Server for SPARC product. The Oracle VM Server for SPARC product has two significant components. The first component is the Oracle VM Manager. This is the same VM Manager that Honglin described for the Oracle VM Server for x86 product. Same management application for both x86 virtualization and SPARC virtualization. There's also a server component for SPARC. This is supported on all T-Series and M-Series SPARC hardware platforms. The fundamental architecture is a high reliability, availability, and serviceability RAS design based upon a concept that we call the service domain separation architecture. There's no single point of failure within the system. Everything can be multi-pathed and redundant. We allow multiple levels of application separation to be used simultaneously on the systems. This includes Solaris zones, the newly introduced Solaris kernel zones, Oracle VM logical domains, as well as electrically isolated physical partitions on M-series systems. All of these separation technologies can be used independently or combined. And of course, we scale to the absolute highest enterprise levels, thousands of CPUs, dozens of terabytes of memory, and large number of virtual machines, any one of which can consume all of the resources available within the hardware platform. Oracle VM Server for SPARC allows a SPARC Solaris-based system to be partitioned and virtualized into multiple separate application domains. Each virtual machine contains its own copy of the Solaris operating system, as well as its own application stack. All of these virtual machines sit on top of a SPARC-based hypervisor that's highly tuned to the SPARC hardware platform, the SPARC microprocessor. This is a firmware-based hypervisor, extremely lightweight. One of its primary duties is to manage the physical resources of the hardware platform, which allows CPUs, memory, and I/O to be partitioned and virtualized and made available to the virtual machines that run on the system. The Oracle VM Server for SPARC product contains all of the capabilities and all of the advanced features that you would expect in an enterprise-grade solution. We offer leading price performance. The Oracle VM Server for SPARC product is free to download, free to use in production. Your support comes through your Solaris support agreement or your SPARC hardware platform support agreement. We offer the highest levels of performance in the industry. We provide secure end-to-end encrypted live migration. We offer the highest levels of virtual I/O performance in the industry. This is both for virtual disk as well as virtual network. And for those customers who demand the absolute top level bare metal performance with maximum efficiency within the system, we provide industry standard single root I/O virtualization for disk, for network, and InfiniBand. And we also offer a direct PCI pass-through capability to the virtual machine, which we call direct I/O. We offer tools to the administrator to be able to move the system's resources between virtual machines wherever the workloads may demand it. This is CPU resources, memory resources, as well as I/O resources, dynamically with no downtime. We have integrated RAS at every level of the software stack, from the hypervisor all the way up to the applications. And we make it easy for our customers to move their legacy environments from older, bare metal SPARC Solaris platforms directly into modern generation, latest Solaris virtualized environments. CPU resources within the system can be managed at the granularity of a single hardware thread up to an entire core. We couple that with a dynamic resource management engine that will automatically move CPU resources between virtual machines based on workload demands and CPU utilization. We integrate platform power management capabilities on a SPARC platform together with virtualization. We offer advanced network configuration and monitoring. And of course, everything that runs with this environment is completely certified, fully supported by Oracle. Let me talk a little bit more about secure live migration. We offer live migration on all SPARC T-Series and M-Series system servers. Customers can live migrate their workloads between T and M-Series platforms, between newer generation and older generation SPARC T-Series platforms, giving you the highest levels of investment protection offered in the industry. All of the secure live migration is performed end-to-end encrypted using hardware crypto acceleration. at no cost to the end user. There's no need for additional managed networks to move your migration traffic on, and it also eliminates any need for redundant components within the system. We offer simply a more secure and more flexible live migration capability. Okay, so what's new with Oracle VM Server for SPARC? In March 2014, we released version 3.1.1. This update of the product added support for fiber channel single root I/O virtualization. So this augments our existing SRIOV capabilities for network and InfiniBand to now offer fiber channel. We offered a number of improvements in terms of virtual network bandwidth control, as well as virtual network management. We offer industry-leading virtual I/O performance. We've made a number of improvements in the hypervisor, in the operating system, and in the Oracle VM Server for SPARC LDOMS Manager. All of these have improved performance for virtual networks as well as virtual disk, making them virtually indistinguishable with bare metal performance. We also have improved some of the capabilities around managing more complex single root I/O virtualization configurations, where commands can now be implemented and executed that operate across a wide range of virtual function devices, instead of having to perform the function over and over for each individual virtual function. In September 2014, the latest version of the Oracle VM Server for SPARC software, version 3.1.1.1, was released. In addition to accumulating a number of bug fix updates in this maintenance release, we also added a couple of additional capabilities. First, we now offer support for private virtual LANs, or PVLANs. We have increased the number of logical domain channel endpoints, or LDCs, per guest by more than doubling. And this is available on platforms beginning with SPARC T4 up to the latest SPARC M6 platform. We also added the ability to dynamically assign PCI plug-in devices, and this is available on Fujitsu M10 systems. This version of Oracle VM Server for SPARC is offered on all SPARC platforms beginning with SPARC T2 up to the very latest SPARC M6 and SPARC M10 platforms. Download instructions for this release are in the usual place. Go to oracle.com/technetwork, servers and storage, VM, and you'll see the downloads page. I'd like to say a little bit more about our private VLAN support. So private VLANs are an industry standard documented in RFC 5517. And the way it works in a SPARC virtualized environment is first the administrator would create a VNIC. And on that VNIC would establish the PVLAN parameters. We now allow those PVLAN attributes to pass down into the logical domain's virtual network device. So down in the logical domains configuration, when an administrator would now create a virtual network based on a VNIC, the add VNet command, you can replicate the same PVLAN characteristics that you've established on the associated VNIC, and that now gets passed down and is honored in the LDOMS virtual network. Also in version 3.1.1.1, we've increased the number of logical domain channels available for each virtual machine. Our goal is that customers should not have to actively manage these LDCs. This should be a resource that's automatically managed inside the system. Today, we have customers with extremely large and extremely complex configurations that are starting to hit the current maximum of 768 LDCs within a virtual machine. Beginning with this release, we've increased the available LDCs per VM by more than 2x to 1,984. Now, that will alleviate any possible resource constrictions that customers are starting to face today without increasing the memory footprint of the hypervisor. This is available on SPARC T4 systems and above. So where are we going in the future with Oracle VM Server for SPARC? The engineering team is currently working on a number of management improvements that will help customers be able to manage their entire stack and get the most out of that stack. There's a number of optimizations with the SPARC hardware and the Solaris operating system that translate directly into a virtualized environment. We will continue to scale and we will continue to support the absolute latest SPARC hardware platforms. We will be taking advantage of some new technology that's coming out in the future SPARC hardware platforms to further accelerate and further reduce overheads associated with operations such as live migration. We're going to be offering a number of observability and manageability improvements, especially in terms of networking and virtual nets. And we will definitely be doing further integration with software-defined networking technology, such as the Elastic Virtual Switch in Solaris. We'll be increasing the overall RAS, scalability, and security of the system and the virtualized environment. Multipathing will continue to see improvements, particularly on the disk, virtual disk side of the world. An important attribute that's going to be rolling out that is coupled with single root I/O virtualization is a technology that we call I/O domain resiliency. So when customers are implementing SRIOV configurations, there'll be no compromise in terms of the ability to multipath and write out system level failures in their IOV environment. There'll also be some further improvements that we're doing in terms of compliance, such as our live migration will be fully compatible with FIPS 140-2 with large cryptographic keys, as well as utilizing the compliant cryptographic algorithms. And with that, I'm going to turn it back to Hong-Lin Su to talk about Oracle VM being proven in the enterprise.
Thank you, John. So more and more customers today use Oracle VM for both x86 and SPARC. So they want to ask, why do so many customers start using? So here I want to share with some of the examples, so why Oracle VM has been used widely in the enterprise. So one good example is Oracle ourselves. We have done tremendous testing for Oracle VM in our internal testing and developer environment. Oracle, the product development, they are heavily used Oracle VM. As you can see from the statistics, there's over 26 million test and production hours per week running on top of the Oracle VM. There are over 22,000 servers and running over 182,000 virtual machines. So the workloads are for both for software and hardware development and corporate infrastructure. So they are running on Oracle hardware, storage, the Solaris, Linux, and running on top of Oracle VM. So the workloads including database, middleware, and Oracle applications. In turn, from the customer-facing side, Oracle VM has been used in Oracle Managed Cloud Services. So the team, they started using Oracle VM even before the Oracle VM for x86 was announced before 2007. So today, it has been running in production to provide over 15,000 virtual machines to support over 550 global customers today. So from SPARC side, we also have a major US National Research Institute that use the new SPARC hardware platform and running Oracle VM Server for SPARC with Solaris 11 on SPARC supercluster. So they're also running the Oracle e-business suite and Oracle database and Oracle PeopleSoft application, provide 10 times faster data operation for the customer business systems. So just a quick summary. So the Oracle VM has been integrated into all layers of Oracle Red Stack. So for Oracle VM template, and including the Oracle RAG database, and the eBusiness Suite, JD Edwards, PeopleSoft, any Oracle application, you name it, there's a pre-configured, pre-built Oracle VM template provide fast deployment. So there's also study shows we have 7 to 10 times fast deployment with Oracle VM compared with other competitive offering. Then the Oracle Linux and Oracle Solaris had also been integrated with Oracle VM, which is also as a base OS for Oracle VM template. They will also have integration with Oracle Virtual Networking. Those had also been used in the Oracle Virtual Compute Appliance and other engineering systems as well. There's no license cost to use with Oracle VM. It's available for both x86 and for SPARC, and the Oracle Enterprise Manager offers end-to-end management from physical to virtual to cloud. At OpenWorld this year, there are a number of virtualization sessions. Maybe if you missed them, definitely you want to find the opportunity to look into the replay or some other session of those material. So for example, there's also a session talk about how to build private cloud with Oracle OpenStack for Oracle Linux and Oracle VM. There's Oracle's virtualization strategy and the roadmap. And there's also hands-on lab for OpenStack. And there's also some additional session you can go through. So this is a session talk about what's new with Oracle Server for x86 and for SPARC. There's also a session talk about the next generation software-defined network. Definitely you want to take a look. There's also one additional session talk about the improvement in terms for the continuous application availability for mission-critical virtualization environment that's really focused on Oracle Server for SPARC. There's also a session for the Oracle VirtualBox for the developer platform, and there's many other more sessions you want to take a look. So there's also hands-on lab you want to explore. So with Oracle VM, particularly for Oracle VM for x86, and those hands-on apps are also built on top of the VirtualBox. So at the demo ground, we have the session for cover Oracle VM for both x86 and for SPARC, and also a session about OpenStack. So we have growing ecosystem for Oracle VM. So especially from the x86 side, that's really the growing ecosystem. At OpenWorld this year, there's a number of partners that come to the Oracle Linux and the virtualization showcase area. To learn more and stay connected with Oracle the virtualization community, simply go to oracle.com/virtualization. There's also Twitter you can follow. There's a Facebook page and the LinkedIn group. And stay tuned with updates from the Oracle's virtualization blog. And you can also watch to the latest video from YouTube/virtualization. Thank you for your interest. Bye-bye.
Hi, I'm Rob Ludeman, Senior Solutions Manager with Oracle Systems Engineering Group. And today we're going to talk about Oracle Virtualization, specifically Oracle VM Server for SPARC. Now this is a technology that we brought over from the Sun Microsystems acquisition. Back then it was something known as logical domains, so if you were familiar with that technology, that's what we've continued with here. We've just rebranded it and brought it under the Oracle VM umbrella, and we designate it as different from the Oracle VM X86 technology by calling it Oracle VM Server for SPARC. But it has in common many of the same characteristics as its cousin, Oracle VM for X86. And today we're going to explore those similarities and why this is a really interesting family of virtualization products for you to consider for your business. So when we talk about virtualization, we kind of make a distinction, right, about application-driven virtualization. Certainly with virtualization, there are some core benefits that any technology that you're going to use should provide, right? And those are generally around cost savings and more infrastructure-led types of things, right? You use virtualization because you can take a whole bunch of server assets and consolidate down to fewer and still have application isolation built in that you may have done by putting apps on different servers in the prior environment. Makes sense. By doing that, also you gain benefits for your data center around lower cost relative to space and cooling, labor costs, facility reduction costs, things of that nature. And those make sense. Any virtualization technology should be able to deliver those business benefits that are at the core. What we're doing with our virtualization technologies, with the Oracle VM family of virtualization products, is we're delivering more, right? We're really focusing on application-centric benefits. We are integrating the management of both the hardware and the software stack, from servers to storage all the way to the end user device, making it more efficient to virtualize how and where you need, but also to do it with some sort of cloud-like features that more automate the types of functionality that you want to bring on board. And of course, we're doing that compared to heterogeneous type of environments. We're doing that with integrated support across the entire stack. So that reduces risk. That gives you a much more simplified method of doing troubleshooting when you only need to deal with one company where we have that integration across the layers. So we're making it easier for you to deploy, easier to manage, and easier to support your virtualization requirements depending on your application or workload. So what is the Oracle VM Server for SPARC architecture, right? So this is something that's supported across all of our SPARC platforms, our entry-level and mid-range that we sometimes refer to as T servers, and then the M series based products, the really highly scalable, large enterprise systems. We've also built this type of virtualization and now have support for that on our big high-end frames. That'll continue with next generation products as well, where you have deep integration of Oracle VM Server for SPARC with those platforms. So we can run in high reliability, availability, serviceability types of environments. We can provide separation of service domains if we need. We also integrate really well with some of the other fantastic virtualization technologies that we have in Solaris, with the zones, with the kernel zones, right? These things coexist and are compatible, giving you extra layers of isolation. You can take an application, you can put it in Oracle VM, and if you want to carve it into different environments and do it in a very lightweight fashion based on that Solaris kernel level, you can have actually zones within that virtual machine. So different levels of virtualization depending on what your requirements are. But the big message is for you, it'll work, right? It's integrated, designed to work together, and also designed for high performance for your scale. So we pay a lot of attention to minimizing the overhead. That's one of the biggest challenges with other virtualization technologies right now. As you spawn more and more virtual machines onto the system, there's greater requirements for memory, there's greater requirements that bog down the CPU and its performance. So if we can drive that utilization or that overhead down to the lowest possible percentage, sub 1%, even just a fraction of a percent, your applications will perform better, but also you'll need to purchase and use less hardware over time, and that improves your TCO. As far as scale goes, for these environments that are just hyper-virtualized, going to hundreds and thousands of VMs, we can drive lots of virtualization. We can do a huge amount of memory per VM. We can do lots of domains per physical partition if that's required, and we've also demonstrated with our customers that we can do it at a much reduced cost compared to the competition. Now, we do have a centralized management framework called Oracle VM Manager, which can be used for your Oracle VM on X86 servers or engineered systems, but also can be used with your Oracle VM Server for SPARC VMs, right? This is centralized, it's web browser based, no client required. You can manage hundreds of those VMs centrally, simplify how you do your management, how you operate with a highly virtualized environment, and we include that virtualization management when you want to use it. Right? So great story, great scalability, doing it at lower cost, and a framework and a great tool that can be leveraged to manage your complex VM environments. So how does this work in practicality, right? So here you just see an example of how we go out and deploy, right? Because some people kind of get confused or wonder, well, what am I doing here? What you see is that we actually have a hypervisor that is built in, right? And so this manages all the VMs that are there. This is the central layer that does that firmware-based capability to communicate to the VMs. And that's the layer that we build into there. And then above that, you have integration, right? You have integration at the OS layer, depending on whether you need logic logical or virtual types of separation. And above that, I've just put in some examples of the types of applications that you could run. But lots of flexibility. This example only shows, 4 VMs. You can go to tens of VMs, even beyond that if you want. Each domain runs with its own dedicated CPU or CPU threads. You can carve across whatever you need. You can workload manage. You can resource balance, depending on the amount of CPU or amount of memory that is required. Great deal of flexibility, and this is just giving you an example of how we would see customers go out and deploy workloads on our Oracle VM Server for SPARC technology. So again, summarizing, very mature. This is a mature technology that's been out for a number of years, developed really hand in hand with our Oracle Solaris and Oracle SPARC server assets. It allows you to build in high levels of virtualization to meet your business needs and do it at no additional cost, no extra contract to sign. We build this in with the maintenance of the servers that you use and would be the SPARC servers or our SPARC-based engineered systems. We focus on low overhead, to minimize the hardware assets that you need to invest in. We want to look at improving levels of latency. We allow you to dynamically resize, create, delete. There's a lot of flexibility in terms of the HA administration and the performance that you can get. We also have support for live migration, so true hot live migration. It wasn't something that we always had in this technology, but that's something that we've had running now for a number of years. You want to pick up and move a VM that's hot, move it to another machine because you want to do a patch or a scheduled outage. You have that flexibility. That's great for business continuity for the users that you're supporting. And if you want to take this a little bit further and you want to ensure true high availability, this is where you see the layering of Solaris development along with Oracle VM. We actually support, and this is built into a lot of our solutions, we support clustering between VMs. So you've got Oracle Clusterware, you've got support for Oracle RAC for the database layers. Our high availability clustering technologies to provide those levels of uptime that you need are built and combined with Oracle VM to give you that application isolation, but to enable you to have HA between machines to provide higher service levels for databases and applications. And there is another benefit here in that Oracle VM Server for SPARC on these systems is recognized as a hard boundary for Oracle software licensing. So take, for example, Oracle Database. You can use Oracle VM to carve up a CPU or fraction of a CPU or CPUs across a system, and that will be recognized as a hard partition boundary, even though it's a virtual partition. So that's something that can also be beneficial. You can carve up only what you need and only pay for the licenses that you're actually using for the database or for that Oracle software asset. So, top to bottom, complete layered server virtualization for our Oracle SPARC and Oracle SPARC engineered systems that we go off in development. So in summary, great technology that fits under the Oracle VM product umbrella. You have the choice of Oracle VM for X86 or SPARC, a centralized management tool to simplify your ability depending on where the application assets live, be they on X86 or be they on SPARC. Both products have great benefits around low overhead, simplify the way you do operation, and we're just really excited about this portfolio and family of virtualization products. So thank you for taking the time to listen to me talk about Oracle VM Server for SPARC. Hi, I'm Rob Ludeman, Senior Solutions Manager with Oracle's Systems Engineering team. And today we're going to talk about one of the pillars of our Oracle virtualization strategy, our Oracle VM designed for X86 servers. It's a great and fascinating technology, complements what we're doing with the Oracle on Oracle strategy over time with hardware and software. And this is also something that you can leverage to be a lot more cost effective with your virtualization deployments compared to sort of the other prevalent technologies that are out there. So that's what we'll explore today. We'll look at exactly what Oracle VM does and what it can deliver for your business, why we built it and delivered it, and some of the benefits that you can use when you go off and use Oracle VM for x86. So first we'll start with talking about kind of why we're doing virtualization. There's a lot of virtualization that's done out there just for virtualization's sake. It seems to be the thing to do, or it's the hot trend, or we need to go virtualize. And we look at it a little bit differently. We look at the fact that we want to provide virtualization and advise our customers who are dealing with complexity in their environments because there's cost-saving benefits. Number one, we can provide server consolidation through virtualization, but also when you're more efficient and effective with the use of resources and you do virtualize, you can reduce your energy, your facility, and labor costs. Now, those are kind of the basic things, right? Every strategy is going to go out and do that with virtualization. What we're going to do is go a step further. We'll do things a little bit more relative to this strategy. So we're actually looking at the applications that you're running, and specifically with the Oracle apps. And we're integrating management across the hardware and the software stack from servers, from storage to the end user device, and we're providing that all with integrated support. Right, so again, virtualization that makes things easier to deploy, manage, and easier support is a huge benefit. You're not just going to want to virtualize just because it's the thing to do, and that's really what we're driving with the Oracle VM umbrella of technologies that we offer. What we're also driving, and is a great new opportunity, is making this a foundation for cloud types of things. So while we're still supporting the traditional enterprise and the needs around going and deploying best-of-breed products and having applications carved up more efficiently and effectively, this is also at the core of our cloud strategy. Right? We're putting the investment and the features and the functionality in that will make it easier for you to deal with the lifecycle types of things around cloud management. So not only we build those features in, but we also certify. Right? You know that when you use Oracle VM X86 that it's going to be certified for the Oracle products and Oracle Enterprise Manager and the applications, middleware, and database, and this is something that we leverage internally as well. Now, not all cloud platforms are built entirely for on-premise or on-premise on Oracle technologies. So we do also certify support for third-party technologies that are out there, for Microsoft Windows and for other Linux distributions, so that you have the flexibility to help integrate this efficiently into your existing environment, no matter what you're running. Now, let's talk a little bit about the architecture, what we can go off and do, and why this is advantageous to some of the other technologies that are out there. So Oracle VM Server installs very quickly, installs on bare metal in about a minute. Right? And we provide support for a number of different guest operating systems. We're a guest for Oracle Solaris on x86, for Oracle Linux, for other flavors of Linux, and for Windows. So regardless of what your requirement is out there, we have support for that. And we have support for not only para-virtualized, but also for hardware virtualized or lockdown sort of virtualized kernels and drivers. You have great performance and scale with this, so that is something that we built in quite a bit, and we pay attention to that with virtualization overall, which is we want to provide the lowest overhead because that reduces your cost, that reduces the need for extra hardware, or reduces the inefficiency around driving true application performance. So you can scale up to hundreds of physical CPUs, huge terabytes of memory, lots of virtual CPUs, and great ratios of terabytes per virtual machine, depending on what your requirements are. Now, a lot of times we get asked, how do I manage this? So one of the great tools that we bring that's complementary to this is we have Oracle VM Manager. That is a centralized management server which provides web browser-based functionality. So there's no client that is required, no additional things to add on or purchase, but you can manage hundreds or thousands of VMs centrally from Oracle VM Manager, this one place, and we provide that advanced virtualization management included with that product. So very complementary strategy. You get the very efficient and highly performant Oracle VM X86 technology that can help you scale and do it at a much lower cost than other technologies out there, and you get a really great management platform to make it much easier to have the visibilities into all the virtual machines that you're out there and that you're running. So that's the architecture. Now we still try to make a distinction between sort of traditional virtualization that's just done because of virtualization's sake versus application driven. And this is where you get that extra layer of Oracle co-engineering and certification that comes into the mix. So we focus on delivering value across the stack. And one of the best ways that we deliver this value is with Oracle VM templates, right? How do we speed your time to deployment of a specific application or a workload? Well, Well, we can go off and develop templates that you can leverage and you can replicate over and over again to start up these various environments. This is something very, very interesting and certainly unique with the strategy that we have on our virtualization. This also goes hand in hand with our virtual assembly builder, again, to make those templates easier to deploy and speed your time to application and service delivery. Why it works? It works because we own the intellectual property. We own support for the database and for the operating systems, for the app servers, for the middleware, and for the specific business applications. So you look, there's a really broad and massive template portfolio. So if you're running an Oracle application or you're doing database work or you're doing middleware and you want to heavily virtualize on X86 types of environments, there's a good chance that there's a template that can help speed your deployment and help you replicate and get to services much faster out there. There's management from entire stack for app to disk when you add in Enterprise Manager. And we've integrated these things into engineered systems. So it's not just our best-of-breed X86 servers, but when you look at engineered systems like the Oracle Database Appliance or Exalogic, Exalytics, or VCA, the Virtual Compute Appliance, these templates go hand in hand to speed time to deployment for customers that choose to use our engineered systems instead of our best-of-breed. But it's your choice. Whichever one of those meets your business needs, Oracle VM can be very strategic to improving efficiencies for how you go to market. So we also develop and test these together. So this is maybe too much of a hidden secret within Oracle, but across all the platforms we have, the engineered systems, we're doing continuous, nightly stack builds on all the applications, the database and the middleware, and the same is true for Oracle VM. Right? We do test and production hours of just astronomical rates. Massive amount of time covering a massive amount of servers, tons of virtual machines. We're running these in our own internal IT, but we're also continually testing different workloads. We're using them in development, using in our corporate infrastructure. And the test environments include, anything that we have in our Oracle stack. How do these work with our Oracle storage? How do they work across our server portfolio, the different operating systems that we build? It's a true testament to the Oracle on Oracle, the hardware on software complete type of message. You get the benefit of knowing that we are running Oracle VM across all the different components. We know how it's going to work. We find issues and fix them before they get out to you in the field. That reduces your risk in deployment. That helps you run more effectively. So let's summarize, right? The Oracle VM advantage, right? The advantage in running Oracle VM for X86 on your platforms instead of the alternative architectures that are out there. Huge scalability, right? We have double the scalability of the other platform that's out there. A lot more VMs, a lot more efficiencies, a lot more virtual CPUs that can be supported. It's also a zero license cost, right? So with any of our complementary technologies, particularly around virtualization and with systems management for the hardware layers, these are things that are built into the right to use for the hardware. For the maintenance support contract, you get the right to use virtualization or systems management like Ops Center. And this is a huge advantage when you look at it and compare to the contracts that you may be signing for multiple years just to use virtualization on your technologies. Enterprise Manager included at no extra cost, or the Oracle VM technology that we talked about earlier. This is going to greatly improve your total cost of ownership and help you avoid costs in just using a virtualization technology. It's fast. Right? This is a huge benefit. Great performance. We can help you virtualize your database and Oracle applications much faster than, say, a VMware out there. And we've even tested this and proven this out, that we can run up to 10 times faster than VMware with Oracle VM in these very mission-critical kind of environments. And this is driven by Oracle. So we're proving that we believe in this technology, and we're sharing that with you by showing how we power our own cloud services, we power our own Oracle product development, IT. We learn from those things, we improve the product, we pass those learnings on to you, and you get to benefit from our use of these types of things in production. So it's a great story. We encourage you to take a look into it. I bet we can help save you some cost in your environment, but also make it more efficient with how you go do application-driven virtualization. So thanks for that. In summary, Oracle VM for X86, a really exciting addition, could be into your portfolio where you're running X86, where perhaps you're using other virtualization. If you're seeing it not scale, if you're not seeing it perform to the levels that you want, or you're just looking at the cost of running it over time, probably a good time to investigate our Oracle VM technologies. Thanks again for taking the time to hear about Oracle VM for X86.
This demo will show you how Oracle VM enables enterprise application deployment in minutes or hours as opposed to days or weeks. Oracle VM Server Virtualization supports both Oracle and non-Oracle applications, is fully certified and supported for virtualizing Oracle software, and is free to download. Installing, configuring, and deploying enterprise applications can be time-consuming and resource-intensive. Virtualizing with Oracle VM can help in not only consolidating servers to reduce capital expenses, but also in providing IT flexibility, agility, and efficiency while saving time and costs. Oracle VM is leading the way in accelerating application deployment with innovative solutions, including Oracle VM Templates and Oracle Virtual Assembly Builder. Oracle VM Templates let you deploy a fully configured software stack by providing pre-installed and pre-configured software images. Oracle VM templates can be fully customized post-install and saved as a gold image to serve as a deployment standard, thereby minimizing risks and variation across multiple instance deployments. Simply download the templates from Oracle or create your own, then import to an Oracle VM instance, deploy, and start up the virtual machine. The virtual machines can be brought up from the Oracle VM Manager browser. While the virtual machine starts, the operating systems and applications are configured with the pre-integrated first boot script. Parameters such as IP address and host name can be modified based on the user's input through the integrated console. Oracle VM templates are available for many products. Download now. While Oracle VM templates are useful for self-contained application solutions, enterprise applications are often comprised of multiple interrelated components. Oracle Virtual Assembly Builder provides the framework for capturing the configuration of all the software components in a multi-tier application. Available only with Oracle VM, Oracle Virtual Assembly Builder makes it possible for complex enterprise applications to be customized and provisioned with minimal to no manual intervention. For example, Oracle Virtual Assembly Builder can deploy a collection of virtual machines that contain WebLogic Server instances and a virtual machine that contains an Oracle database instance, and then automatically configure the connection among all the virtual machine instances, a process that would have previously required administrative assistance. Creating an assembly consists of 3 steps. First, Oracle Virtual Assembly Builder introspects each of the software components to capture the configurations into individual software appliances. These appliances expose not only VM configuration properties like memory, CPU, and disk, but also deployment-specific properties unique to the software component packaged in those appliances. Next, it allows users to create multi-tier application assemblies by wiring the appliances together to represent the desired application topology. Then, it provides a single-step template-based deployment capability to provision the entire assembly into the virtualized environment. By using Oracle VM templates and Oracle Virtual Assembly Builder, you can realize the true benefit of virtualization. Put the power of Oracle VM to work in your data center.
My name is Vamsi Nagineni. I'm a principal software engineer in Oracle Systems Group. I work for Solaris Revenue Product Engineering. I have experience of 8 years working in Solaris kernel space. In today's session, we are discussing about Oracle VM Server for SPARC, also known as logical domains. We'll discuss about overview of logical domains technology and its configuration, advanced configuration of the logical domains, and we'll end up with the best practices of the logical domains. Agenda of the today's session is we are going to discuss about SPARC virtualization offerings and a brief overview of LDOMs, and then some of the advanced configuration what we can do with LDOMs, and finally we can discuss about best practices for our logical domains. So looking at the SPARC virtualization, we are offering 3 solutions, 3 different types of virtualization solutions on the SPARC platform. And the first one is dynamic domains. So dynamic domains is typically a dynamic hardware partitioning. Complete hardware resources can be partitioned and number of domains can be created on a single machine. So for example, our M series machines will provide this dynamic domains. So there is no virtualization layer as such like typical type 1 or type 2 hypervisor solutions, but the partitioning will be done at the very hardware level as in ILOM, and typically resources can be separated and given to the different domains. So every domain will have its own IO resources, and IO is pretty much direct. And coming to the next solution, which is called as Oracle VM Server for SPARC, which is also known as logical domains. So logical domains is a para-virtualized solution. So para-virtualization solution is typically a hypervisor comes into picture on top of hardware. On top of this hypervisor, a control domain runs, and this hypervisor has a control of whole hardware of the machine, like all the resources, CPU, memory, and all the IO resources. So another type of solution is, if you compare para-virtualization with full virtualization, the advantage of the para-virtualization is there is no simulation layer required as like in a full virtualization, because the simulation comes into picture when in full virtualization a IO need to be modified, or any sensitive instructions need to be modified in VMM layer. So that is a overhead for IO in a full virtualization. So the advantage with para-virtualization solution is there is no overhead of such a layer here. So all the IOs directly reach to the hypervisor, and IO can be performed. Typically LDOMS is a para-virtualization solution where a hypervisor runs on top of firmware, and on top of this number of domains can be run on a single server. So coming to the next solution, what we call Oracle Solaris zones, which is typically a different type of virtualization solution called operating system virtualization. So here the single instance of operating system will provide number of virtual instances on a single operating system, and this is typically for application environment. So bounded environment can be able to provide different services which can be isolated and typically run as a operating system. So if we look at after discussing all these three type of virtualization solutions, if you look at layered consolidation, brief idea on how does it look like. So a single server with one PDOM and one LDOM and 64 zones. So the red blocks is representing the zones here. So this is typically one kind of consolidation which is simple, and the right side it's an example of a complex configuration where a single server is created with 4 primary domains, 4 or dynamic domains, and with 64 LDOMs and 64 zones. This is a much more isolated environment, and the picture the second picture from the right, which is representing 4 primary domains, 16 logical domains and 64 zones, and the picture next to that is giving 1 PDOM, 4 logical domains and 64 zones. So what is this picture representing? Like if you see, so this is again split into 4 primary domains, and so if you look at the picture at the left is giving a more simpler configuration, and the picture at the right is giving a more complex configuration. So what does it mean? So the left side is like gives you the trend, gives you to the more flexibility and simplicity, and the right side is gives to more isolation, more environments, virtual environments you can run, more isolation, more resource configurations coming to picture, and it's a more complex configuration as well. Depends on your one's requirement, it can be modified as like anything. So coming to the logical domains. So how do you define a logical domain? Logical domain is a virtual machine instance which has its own set of resources. Resources is here a CPU or memory and any IO devices attached to it. So in logical domains, there is a hypervisor support. As I said, in a para-virtualization solution, the hypervisor comes into picture at the firmware level. So the hypervisor is responsible for owning all the hardware resources in the machine. and it provides all the services to the other guest domains as well. So this hypervisor sits on the firmware, and hypervisor provides a logical domains channel, a communication channel between all the domains, which is responsible for providing I/O services. And all the communications happens in the format of service request messages, which will be queued and dequeued as per the processing. So based on the roles a logical domains is performing, we will name the logical domains as like. So there are those 5 types of domains in a logical domain. So the first one is a control domain. Control domain is also known as a primary domain, which has whole control of all the resources. If the control domain has owned any PCI devices, direct endpoint devices, it is called as a root domain. If the control domains owns any direct IO devices or PCI endpoint devices directly, it is called as IO domain. So typically this control domain, root domain and IO domain can provide a virtual services, virtual disk or virtual network services to other domains. So when these are providing a virtual services to other domains, that is called as a service domain. So coming last, it is a guest domain. So guest domains is typically a guest virtual machine which is having the IO through all virtual. So you can define it as a domain which has a virtual IO is a guest domain. So typically a control domain should provide a services to a guest domain. So typical services are which need to be run in the control domain are for virtual network and virtual storage and virtual consoles. These 3 services in the control domain provide enough services to a guest domain which can provide all the virtual services and fully provide a bound environment to run an independent operating system. So coming to the virtual network, so we have a VNet, which is emulated Ethernet device inside a guest domain, and VSW, which is also known as a virtual switch. So virtual switch is a service which runs in a control domain which is responsible for routing the network messages. And coming to the virtual storage, so VDC is a virtual disk client which exports a block device inside a guest domain. So the disk service to the guest is provided through VDC. And coming to the VDS, which is a virtual disk server. So virtual disk server runs in a control domain which abstracts all the disk devices underneath it. So what I mean is all the disk devices in the machine, whether it could be real physical disk or SAN disk, whatever. So it will be managed by a virtual disk server, and on top of the virtual disk server, it will import those disks to a guest domain through VDC. So VDS is responsible for all managing all the disk devices which need to be serviced by the guest domains. Or which need to be required, might be required for the guest domains. So coming to the virtual console, so every guest domain needs a console service. We need to have its own console to look at all the console messages, right? So VCC is a service which runs in a control domain, which is called Virtual Console Concentrator. So which gives the independent consoles to all the logical domains, and it multiplexes all the messages and independently displayed through its own console through VNNTS daemon. So it is a virtual network terminal server daemon. So it provides a console connection through a unique socket, and so console services to every domain are unique, and it runs through a different port. So if we look at the simple configuration of the logical domains, so here the layer of hypervisor comes into picture. On top of hypervisor, there was a control domain running, which is running a virtual switch service, virtual disk server service, and LDMD. I'll tell about LDMD. So the management of logical domains is through a command, everything. So whatever you manage with the logical domains is through LDM command in the control domain. So LDM command will interact through the LDM daemon, which runs in a control daemon, which is actually responsible for managing all these logical domains, the configuration of the logical domains. So coming, the next is a VCC, Virtual Console Concentrator, which interacts through VNTS daemon. So these all services together will provide guest domain services, all the domain services to all the guest domains. So there are 4 guest domains running in the picture with its own VNet device, which is a emulated Ethernet device, and VDC, which is a guest domain's own block device. So what are the real domain resources? Every domain needs its own CPU, own memory, and it requires disk, and it requires a network interface for the network I/O, and it should have its own console. So actually virtual devices, all the virtual devices will be abstracting underlying actual physical devices through a control domain. So if you look at the allocation model through LDM, LDM command, you are responsible to assign a resources to the logical domain. So typically what you allocate is a CPU and memory, which are the critical resources. The domain will have its own independent memory, and CPU and memory are never oversubscribed. What I mean is, if you have 100 CPUs in the machine, you can configure only 100 CPUs to the domains. So you can never oversubscribe. You can't configure 200 CPUs to a domain if you have only 100 CPUs. So the LDM command will identify itself, and it gives the failure. The domains can be dynamically reconfigurable or statically reconfigurable as per the user option. And the live migration, which is a powerful feature, is allowed with the logical domains. So coming to the I/O to the domains, it can be either physical or a virtual I/O. So in the case of physical I/O, so a domain should own either a complete PCI bus which is connected to the direct physical backend devices, or it can be assigned with a PCI endpoint device, or it could be SRIOV virtual function. So we will discuss SRIOV probably later. So these three typical options will provide a direct I/O to the domains. So physical I/O can give you a native performance without any overhead. So coming to the virtual I/O, so the I/O services can be provided to the control domain with the help of all the virtual services running there. So the advantage of the limitation of physical I/O is live migration is not allowed, but with a virtual I/O, the domains running with a virtual I/O, the live migration is allowed. Though you cannot get the native performance with I/O, but it can be near native because all the virtual drivers has been implemented as such. It can give you the native performance, near to native performance. So virtual I/O, the domain, the control domain or service domain abstracts the underlying actual I/O resources, and the actual implementation is through logical domain channels. So it provides more security, more bounded environment as such, and the virtual I/O services can give you the flexibility of redundancy or resiliency, and is the most proved flexible way of configuring I/O to the domains, because there is no limitation of the direct device attachment. So you can run any number of clients through these virtual services and offer to any number of guest domains. So a service domain can provide a virtual disk and virtual NIC for a network interface, and virtual disk for a storage, and typically virtual switches for it can configure virtual switches which can be used for the interdomain networking. So it will have its own emulated Ethernet device as well, which is called a VNet. So if you look at the picture of virtualized I/O in detail, so this picture is giving you one service domain configuration which is attached to a direct PCI 400 bus control, which has its own NIC card, which has its own HBA card, which is connected to the SAN array. So this PCI is providing a network interfaces and disk interfaces. So this PCI is attached to the service domain, which can in turn provide this disk services and network services to the guest domains. So typically, if you see on the MAC layer, we configured a virtual switch. So virtual switch through logical domains is interacting with the VNet device in a guest domains, which is responsible for providing the network services. All the messages will be routed through the switch from the control domain. So this is typically a virtual I/O picture, and similarly the disk services is provided through the VDC. VDC is a typical a disk client which is exported inside a guest domain. On top of it, you can create your own file system, and all these disk messages will be queued into this logical domain channel, and the VDS in the service domain, which is actually on top of storage stack, will be responsible for doing the actual read, write, or whatever the I/O on the disk. So VDS is a virtual disk server, as I mentioned, which runs in the control domain, which manages all the disks in the machine, or It could be SAN NAS or NAS disk or ISKC attached to the ISKC. And VDS we typically run in a service domain. There is no limitation as such, like one VDS has to manage this many disks only. So one VDS is sufficient for one control domain, and it can scale for any number of CPUs. So if you look at the actual virtual disk backend, so virtual disk backend can be a real physical device or a real or a physical disk as mentioned here, or it could be a slice of the disk. So, or either it could be a logical disk backend, or typically if you create a file which is a block device. So typically on any ZFS, UFS or any other file system, if you create a file as a block file and you can offer it to a virtual disk server, which in turn can be provided to the guest domain. So the other type of backend you can give to the guest domain is a ZFS volume or any other volume from the typical volume manager like SVM or VXVM. You create a volume and attach it to the VDS server. So ZFS can be very useful in creating snapshots and clones very fast and very powerful, but the limitation with the ZFS is zpool can be imported to the one guest domain at a time. So it could be a limitation for the migration, because if you want to migrate guest domain from one machine to the other machine, so running a domain on a zpool directly is a bad idea. So coming to the virtual network. So we run a virtual switch service on a control domain which is responsible for routing messages to the real backend physical NIC. So every virtual switch need to be backed by a real physical NIC card. So it could be anything, Intel IXGB card or whatever which is given with the machine. So the virtual switch which is running on top of this physical NIC is responsible for providing network services in the guest domain. So the virtual switch need not be backed by the real backend, especially for inter-domain traffic. If you want a virtual switch configured for the network for all the guest domains in a single machine, it need not be backed by a real physical NIC card. So it either could be backed by a physical NIC card or need not be for a local virtual switch. So all the Ethernet interfaces inside a guest domain will be having the naming convention as a VNet N. N is a number here, so whatever number you queue while configuring the virtual network to the guest domain. So this naming convention as such, this will be imported inside a guest domain and it will be visible as such. So your virtual network interface name inside a guest domain could be like VNet 1 or VNet 2 as you gave at the time of the configuration. So you can for redundancy you can always configure IPMP by importing two virtual network interfaces in a guest domain. So coming to the virtual console, as I said, VCC is a service which need to be run on the virtual on the control domain. So you will configure this at one time and give you the port range on which you need a console connections. And this VCC interacts through this VNTS daemon and provide the console services. And this VCC, all the console IO from the guest domain will be routed through this VCC service. So till now we discussed all about the virtual IO. So quick, if we do the quick review of virtual IO. So typically three services. So the critical services for the virtual IO are disk, network and console, and this will be provided by three services in the control domain. You need to configure these three services in the control domain for one time, and the management is all through LDM command later. So the other option for IO in the guest domains is a direct IO. So you can provide a direct IO by assigning a complete PCA root complex or any PCA endpoint devices, or either it could be SRIOV virtual functions. So if you look at the PCA bus assignment, so I have a machine with two PCA root complexes. So what I did is I split it and assigned to the two domains in a machine. So typically these two domains, so the primary is still a primary, and the whatever you separated from the primary which you assign to another guest domain, that will become IO domain now, because it will be having the direct IO. There won't be hypervisor in picture for the IO. And if this PCI switch has any endpoint network or a endpoint network device, or if it has an endpoint disk or HPA array, this domain will be having the direct I/O for especially for network and disk. But ensure always the guest domain should be having its own network and own disk devices. When you are splitting, you need to be careful. Careful to look at what are the endpoint devices to the PCI bus, and it doesn't make sense if you split the PCI switch which doesn't have a network device, for example, because you won't get the direct I/O for a network inside a guest domain. So if you look at the root domain configuration, so root domain is nothing but which has its own PCI root complex. So here I have two PCI root complexes, that is PCI 400 and PCI 500. So typically these guest domains are called as root domains when they have their own PCI root complexes. And coming to the guest domain, so typically this guest domain, the endpoint device is attached to the PCI 400 bus is been assigned to the guest domain. So this guest domain also indirectly having a direct I/O feature, because the endpoint device is directly connected to the guest domain. So this guest domain in this case is a typical example of I/O domain, because this is been assigned with the direct PCI endpoint device. So if you see the direct I/O, another direct I/O picture, these guest domains, we have two guest domains which is attached with the PCI endpoint devices, which are called as I/O domains, and this right side is a root domain which owns the complete PCI 400 bus. So SRIOV is a feature which is advanced I/O virtualization. Typically some of the devices has its own virtualization capabilities by providing virtual functions. So a virtual function is nothing but it appears like as a multiple physical devices to the hypervisor, though it is a single device. So this is a PCIe extension feature which can provide a direct I/O feasibility to the guest domains. Each virtual function will be having a direct access to the device DMA and some of the control registers, and the I/O overhead can be minimized a lot and can be bring near to the native I/O performance. So, but the limitation of this is actually the end device should have the virtualization capability, and it should be SRIOV supported. So, for example, we have Intel IXGB card which has SRIOV enabled, and some of the MLX devices and FC fiber channel endpoints are SRIOV enabled. So the direct I/O can be provided to the guest domain by assigning these virtual functions. Need not be PCI endpoint device or PCI root complex all the times, but providing this virtual function to the domains will give you the direct I/O facility to the guest domain and more performance than virtual I/O. So we'll look at a simple configuration for the domains through the commands what need to be done. So typically Solaris 11 is preferred for the control domain. Once you install the machine with Solaris 11, make sure the LDOM manager package is installed on the machine. LDOM manager comes by default, so you need not specially install that package. So but make sure the service LDMD is enabled in the machine. For control service I/O domains, always Solaris 11 is preferred, but you can mix and match Solaris 11 and Solaris 10 in guest domains. Define initial configuration, and first time you need to reboot the primary domain, and once you reboot the primary domain, all the resources will be typically available for assigning it to the guest domains. So I'll walk through all the commands required for the initial configurations. Once you boot the machine which is supported with for example Sun 4V or any T series machines which supports logical domains, the first step you need to do is to start the services, all the virtual services required for all the three virtual services need to be enabled, which is virtual disk server add VDS. This is add VDS, and we are giving a primary VDS0 as a service name, and we are creating it in a primary. Primary is a default control domain name which lies in the machine, and after that we are configuring a VCC service through add VCC command, and the port range we are giving as a 5000 to 5100. So these consoles will be created on this typically from these ports, and our VCC service name is primary VCC0. It could be anything, there is no limitation. We need to give the naming format as like this, but it's for easiness we are creating this way. and we are assigning to the primary domain primary. And the third service is a vSwitch, and the vSwitch is backed up with the actual network interface, which is Net0. Net0 is so whatever the real physical NIC on the machine, Net0 is a imported network interface name. So Net0 is backed up by this vSwitch, and we are giving the name of this vSwitch service as a primary VSW0, and the primary is a domain name. These are the, once you start these three typical services which are responsible for creating virtual IO, the next step is to configure the CPU and memory for the primary domain. So we do assign CPUs either through setcore or setv CPU, and so one need to decide what are the actual resources needed by the primary domain and assign accordingly. So we are assigning 2 cores here to the primary domain. After that we are doing start reconf. So start reconf is a dynamic reconfigurable, will be disabled. So what I meant is whatever the steps we are doing later, it will be effective only after reboot. So once I do the start reconf and do the set memory of 16 gig, so it won't try to assign a memory to the primary domain dynamically. So it will be affected only after the reboot. So once you set the memory and set the number of cores or the CPU, you just save the configuration. So saving the configuration is a mandatory step here. So otherwise there will be a risk of losing it. Every configurations while you are doing, it is recommended to save the configuration all the times. So I do save all this configuration with ldm add config, and I am giving this configuration name as a initial. So initial is the name of the configuration, and later I am doing the reboot of the primary domain. So what does it mean? So once you reboot the primary domain, so all the services will be activated, and your primary domain will be assigned with 2 cores and 16 gig of memory, and the remaining whole memory and CPUs will be available in pool, which can be assigned to the guest domains. And if you are configuring a primary domain in Solaris 10, though it is not recommended, so you at the place of netdev you should give the actual interface name as IXGB0 or IGB or whatever, because the network interfaces in Solaris 11 and Solaris 10 is changed a lot, but it is recommended to always run Solaris 11 in a control domain. But it is recommended to always evaluate the workload running in the primary domain and assign or change the resources or assign the resources accordingly. So let's look at creating a guest domain. So I am adding a domain with the name ldom1, and I am setting a vCPU 16. I am giving 16 vCPUs to the ldom1, and I am setting memory 16 gig to this guest domain ldom1. So the CPU and memory are done. So what next? We need to give a network interface, and we need to give a disk interface to install its own boot image. So either you can give as a backend file image or a block device file to the control domain. So I am creating a 10 gig file with disk0.img naming convention on top of any file system. So typically any slice disk or any backend file should be attached first to the VDS virtual disk server. So how do we do that? So I am attaching this image to the VDS through add VDS dev. This is a server side. Please remember this is a process of attaching a disk to the server, that is virtual disk server. Add VDS dev, and I am giving this image file, and this is a volume name in the control domain. I am giving vol10 as a volume name, and at the rate the VDS service name. So this is the naming convention to be followed. Remember, I am iterating it again. This is a volume name of this disk, and this is the primary VDS0 is a virtual disk server name. So once you attach this image file or a disk directly to the VDS server, then you need to import this device inside the guest domain. So how do we do that? That is through add vdisk, add-vdisk, and this vdisk10 is the name of the disk which will be imported inside the guest domain. So inside the guest domain you will see this disk as with the name vdisk10. And so what is the volume you are importing? So wall 10 at primary VDS 0, what is exactly given here? So this is a volume name what we have given for the virtual disk server, and finally a logical domain name LDOM1. So once these two steps are done, a disk will be imported for a guest domain, and inside a guest domain this disk will be visible as a vdisk10. The same example for a real backend device. This is image file. This is a direct physical disk or a slice, and it will be more faster than the image file as mentioned above. So I am adding this adding this slice 0 to the VDS server as a much faster disk name at a primary VDS 0, and later I am adding this vdisk with a name of much faster vdisk, which is imported inside a guest domain, to the LDOM1, and this is again, this name is same as the volume name which is imported to the VDS. So after all these steps done, and the other step is add VNet. So add VNet is importing a virtual network interface to the guest domain. So I am giving a name of VNet1 to be visible inside a guest domain, and the switch servicing this Ethernet emulated Ethernet device is primary VSW0 as we given in the previous slide, and the LDOM1 is a logical domain. So we have assigned after vCPU and memory, we have assigned the virtual network interface and the virtual disk to the guest domain. So now the domain will be in unbinded state. Our next step should be to bind this domain, which is through LDM bind. So after this, the domain will be bounded, all the CPU and memory topology will be effective, and it will be dedicated to the guest domain. LDM, if you look at LDM list LDOM1, it will tell you all the configuration, what port has been assigned for the console, and how many vCPUs, and how much of memory is given to the guest domain. And for the virtual disk services, the backend could be the ISO image as well. If you have an ISO image to install any Solaris 11 or Solaris 10, keep ISO image in your own machine or through NFS path, and you provide it to the virtual disk server, and this ISO typically will be helpful in installing the guest operating system for the first time.